This is part 2 of lesson 10.3 for 8th grade accelerated math. We're going to now talk about transformations, and transformations involve a couple of different types of transformations, and so we're going to start out with some translations today. But before we do that, let's talk about a couple of words. So the word image, when I talk about an image, it's the new figure after a transformation has taken place. So when we talk about transformations, we're going to talk about movement of shapes. And you have seen these before, but when you take a shape and like a translation means you're going to like slide it. And so this would be the image, your new shape, and then this would be called the pre-image. So the word pre, or the prefix pre, means before. So the image before is the pre-image, and the image after the transformation takes place is the image. Okay, then the second vocabulary, transformation, that's just a general form and explains how the pre-image becomes the image. And so there's different types of transformations that we're going to study. So we're going to talk about translations, and then we're going to talk about reflections, and then there's rotations. Now previously, last year you talked about dilations. We're not going to do those this year, but we will see them again in secondary 2 math. So these are the 3 that we're going to talk about this year. Okay, so a translation is what we're going to talk about today. So a translation, it's also known as a slide. Okay, and so sometimes when people say a slide, it just means you're shifting something around. And so it slides a figure from one position to another. It does not change the size, shape, or orientation. So orientation means it's not going to be turned a different way. So if you have a figure like this and you slide it, it's going to be exactly the same figure. It's not going to be turned or flipped or anything else. It's going to be the same size, shape, everything. So congruent figures. The pre-image and the image of that will be congruent. So congruence. Okay, the line segments. Now when you do a translation, the line segments between the image and the pre-image are parallel, and they have the same length. So what I mean by that is, if we have a shape like this, pretend that that's straight, and we are going to slide it to the right and up a little bit. If we were to connect the pre-image with the image with lines connecting their vertices, those line segments are going to be parallel and they're going to be congruent. So they're all the same size, length, everything like that. So that's a characteristic of translations. Now when we write about a translation, we use something called the translation rule. And so when you talk about translations, this is how you need to write it. So first off, you say the point xy, and then you're going to say it changes according to this. That's what the arrow means, so you can't leave the arrow out. And then you're going to say the x is going to be changed by a. So if you're going to move it right, you'd say plus 2, so x plus 2. If you're going to move it left, then you would say like x minus 3. And then y plus b. So again, if you're going to move it up, you'd say y plus 4. If you're going to move it down, you'd say y minus 4. So something like that. So that translates a figure a units to the right or left and b units up or down. So we're going to practice writing our translation rule like that. Okay, one more vocabulary is the word isometry. An isometry is any type of transformation that preserves the length, and so that means it doesn't get bigger or smaller. So the ones that we're going to study this year are a translation, rotation, and reflection, and they are all isometries. A transformation that's not an isometry is a dilation, and that's why you studied it last year, because that goes with similar figures, not congruent figures. And since this year we're talking about congruent figures, we're not going to be talking about dilation. So all of ours this year will be isometries. Okay, we're just going to do a couple of examples because translations are really very intuitive. And so number 11 in your notes, it says, given quadrilateral ABCD, we're going to graph the image. So this right here, this is the pre-image. So we're going to graph the image of quadrilateral ABCD that has been translated according to this rule. So that rule tells me that I'm going to take my x's and I'm going to move them to the right 3. So take all of your points and I'm going to move them 3. So 1, 2, 3. So this is going to be called A prime. And sorry, that's not A prime yet, because then we're also going to move it down 2. So I'm going to go to the right 3 and down 2. This is going to be A prime. So B, I'm going to move it to the right 3 and down 2, and this will be B prime. D, same thing, and C. Okay, when you're done making all of those movements, then you're going to get a straight edge. You need to use a straight edge. I don't want to see any wobbly lines, but you're going to get a straight edge and you're going to connect these points and you're going to make a new quadrilateral that will be congruent to our pre-image. And so we can say A prime, B prime, C prime, D prime is congruent to A, B, C, D. Okay, another thing based on something we just read is that the length from A to A prime is congruent to the length of D to D prime, and that's congruent to C to C prime. And you can use the distance formula or Pythagorean theorem to check and make sure that that's true, but these are all going to be congruent. Not only that, but according to what we just said, is that they're going to be parallel. And if you look at the slopes of each one of those, all of those have a slope of negative 2/3, and so they're all parallel. And so if you ended up with something where the lines connecting the pre-image and the image were not parallel, then you did not do a transformation correctly as far as a translation goes. Okay, the next one we're going to kind of turn it around and we're going to say, given that quadrilateral MNOP has these vertices, so I don't have a picture for you, but I'm telling you what it looks like. You're going to find the vertices for a quadrilateral M prime, N prime, O prime, P prime, given this transformation rule. So we don't actually have to draw it to know what it's going to do. So since I know that I'm going to take my x coordinates and subtract 3 and my y coordinates and add 7, I know that M prime will be 2 minus 3 and 6 plus 7. Now you don't have to write all of that. You can just write that M prime is going to be negative 1, 13. And then N prime is going to be negative 3 minus 3, because I take the negative 3 and then minus the 3, and then 4 plus 7. Now you can just write negative 6, 11. That's fine. And then same with O prime. That's going to be the 1, 0, so 1 minus 3, and then 0 plus 7. And then P prime is going to be negative 5 minus 3, and 12 plus 7. And so these are going to be the vertices of my image. And so if I was to graph the pre-image and the image, I would use those vertices. So with that, you are ready to complete your homework.